Hello everyone, I welcome you all to this class. Today we'll be considering this aspect of a partial derivative, the one we call total partial derivative, or you can call it what? Chain rule. So in this class I will show you how to perform a total partial derivative, which is using the knowledge of chain rule to perform partial derivative. So assuming that u is a function of xy and x is a function of other two variables, s and t, and y2 is a function of other two variables, s and t. This is what we call function of a function. U is a function of xy. X2 is a function of another two variables. Y is also a function of that two variables. So I want to know how I can perform partial derivative of u with respect to s, partial derivative of u with respect to t. Now, partial derivative of u with respect to x will now be partial derivative of u with respect to x multiplied by partial derivative of x with respect to what? S, plus partial derivative of u with respect to y multiplied by partial derivative of y with respect to what? S. Now, if you want to perform partial derivative of u with respect to t, you can guess what it will be. Partial derivative of u with respect to t will be partial derivative of u with respect to x multiplied by partial derivative of x with respect to t plus partial derivative of u with respect to y multiplied by what? Partial derivative of y with respect to what? T. So this is how to make use of what? Chain rule. So let's look at how we can apply this using this example. Now example 1 says let w be equal to ln of x squared plus y squared plus z squared, where x is equal to s minus t and y is equal to s plus t and z is equal to 2 square root of st. We want to find partial w, partial s, and then partial w, partial what? T. So let's look at solution to this problem. Solution. Now, what is the first one? Let's look at this first one. Let me call it number 1. What is partial w, partial s? Partial w, partial s. So we're using this knowledge of the one we have done earlier. Partial w, partial x will be what? Partial w, partial, because w is a function of x, y, z. So if I want to differentiate w with respect to s, I'll first of all differentiate w with respect to x multiply by, you differentiate x with respect to what? S, because x is a function of s too, plus, because I have more than one variable, I will come to w again, differentiate w with respect to the second variable, partial w, partial y, times, you differentiate that second variable, which is y, with respect to what? S, partial y, partial s, plus partial w, partial, the third variable is what? Z, z times partial z, partial s, partial z, partial s, because z is a function of s. So let's get the respective solution. Now this will be equal to, now what is partial w partial x? Let's get the result. Now partial w, let me call this one equation 1. Let me get those answers and substitute. Now partial w partial x will be equal to, now what is the function you have? Log. How do you differentiate log? Assuming you are given y equals log of, that's ln of x squared minus 3. And you are asked to differentiate to find dy dx. What will it be? If you want to differentiate len or log, well, how do you perform the derivative? So if you want to differentiate it, you differentiate what is inside. What is inside is what? X squared minus 3. If you differentiate this with respect to x, what will you get? 2x. So that answer you got to write it 2x divided by the whole of the function you have inside the log. What is the whole of the function? X squared minus 3. So that's a similar thing we are going to do. So now we have a ln of x squared plus y squared plus z squared. Then I want to perform partial derivative of w with respect to x alone. So I will treat y and z as what? A constant, and derivative of constant is what? 0. You differentiate what is inside the ln. What is inside is this. So if I differentiate this with respect to x, this will be 0, this will be 0, because they are constants. So if I differentiate x squared, I will get what? 2x. You divide it by the whole of the quantity you have inside the ln, divided by x squared plus y squared plus z squared. That's it. Then similarly, what is partial w partial y? In similar way, you can get, this time around you now differentiate this y inside the ln. You have 2y divided by the whole of the quantity, x squared plus y squared plus z squared. Then what is partial w partial z? Will be equal to what? You differentiate the what is inside the ln with respect to z, which is 2z divided by x squared, 2z divided by x squared plus y squared plus z squared. So this is what you now have. So I've gotten partial w partial x, partial w partial y, partial w partial what? Z. So what is partial x partial? What is partial x partial s? Partial x partial s will be equal to what? See your x here, differentiate it with respect to, this is your x, differentiate with respect to s. You are now treating t as what? A constant, because x is a function of s and what? T. So you want to perform partial derivative of x with respect to s alone. So this t, you are treating it as a number, as a constant. So the derivative of this constant is 0. So what is derivative of s? Is 1. Partial, what is the other one? Partial y partial s. I will treat t as a constant. I'm differentiating y with respect to what? S. So what is derivative of s? Just like, yes, what is derivative of s? You get 1. Then partial z partial s will be what? Partial z partial s. What is our z? Our z is 2 square root of st, which I can write as 2 multiplying st raised to power what? Half. Since square root is the same thing as power half. I want to differentiate this with respect to what? With respect to s. What do? I will use chain rule. I will differentiate the inside with respect to s. Inside is st. Differentiate st with respect to x. You are treating t as just as a number, just like you have 2s. And if I ask to differentiate 2s with respect to x, you get what? 2. So if you differentiate st with respect to s, you get what? T. So you get t, so you now have t, multiply by, you differentiate the bracket. What's the index of the bracket? Half. You bring it down. So 1 over 2, we have 2 before here, 2 into st raised to power. You remove 1 from this, half minus 1. So what will you have? So what will you have now? 2, we cancel this 2. So you have t, open bracket, st raised to power what? Half minus 1 is negative half. Negative half. Therefore, partial w partial s will be equal to, what we have, partial w partial x gave us what? It gave us 2x into x squared plus y squared plus z squared. Multiply by, what is a partial x partial s? It gave us what? 1. So if you multiply it by 1, you will just have this quantity left. Multiply by 1 plus, what is partial w partial y? It gave us 2y divided by x squared plus y squared plus z squared times, what is partial y partial s? Partial y partial s is 1 plus, what is partial w partial z? Give us 2z divided by x squared plus y squared plus z squared. Multiply by, what is partial z partial s? It gave us t into st raised to power negative half. All of them will have common denominator. So I have x squared, y squared, z squared divided by 1 times 2x, I have 2x, plus 1 times 2y, I have 2y, plus 2z times t into st raised to power negative half, I have 2z t st raised to power negative half. So this is the result of that. Now the second one is, we are going to find the second one. So let's find the second. Let's find the second one. What is the second one? Is a partial w partial t. Partial w partial t. You just mimic this one we have written here. Partial w partial t will be what? Partial w partial x times partial x partial t instead of s now, just as we have it here. Instead of s now is now t, because I want to differentiate with respect to t, plus partial w partial y times partial y partial t plus partial w partial z times partial z partial t. So this is what you will now have. So let's do the substitution here. So we have gotten this one before. We have gotten partial w partial x before, partial w partial y, and partial w partial z before, right? We have gotten it. So what is now remaining is we need to get a partial x partial t. Now what is partial x partial t? Because of space, I clean what x. They told us that x is equals to s minus t. So if you differentiate this x with respect to t, you are treating s as a constant. Derivative of constant is what? 0. So what is it? You now differentiate negative t, you get what? Negative 1. You get negative 1. Partial y partial t. If you want to get partial y partial t, see your y here. You are treating s as a constant. So derivative of s, which is a constant, will be 0. You differentiate t because you are differentiating with respect to t. That's why you are treating s as a constant. So you differentiate t, you get what? 1. Partial z partial t will be what? Remember your z is 2 square root of st, which you wrote as, let me create space here, which you wrote as, we have z is equals to 2 square root of st, which we wrote as 2 open bracket st raised to power half, right? Now I want to differentiate this with respect to t. So what is inside is what? St. if you are treating s as a constant, you are differentiating with respect to t. If you differentiate with respect to t, differentiate this t, what will you get? You have your s left. You have s times, you have 2 times, you bring down the, differentiate the bracket. What's the index of the bracket? Half. Times this quantity 2 into st. You remove 1 from the index. Half minus 1. So what will you have? 2 will cancel 2. You have s, open bracket, st. Half minus 1 is negative half. So what do? You substitute. So therefore, partial w partial t will be equals to partial w partial x. You can check from the previous thing we have solved. Partial w partial x gave us 2x divided by x squared plus y squared plus z squared. We are multiplying it by what? Partial x partial t, which gave us negative 1. Plus, what is partial w partial y? It gave us 2y divided by x squared plus y squared plus z squared. Multiply by what is partial y partial t? It gave us 1. Plus, what is partial z what is partial w partial z? Give us 2z into x squared plus y squared plus z squared times partial z partial t. Partial z partial t gave us s into st raised to the power negative half. So what do? Both of them has common denominator. So the common denominator is x squared plus y squared plus z squared. So now negative 1 multiplied to x, I have negative 2x plus 2y multiply 1, I have 2y plus 2z multiply s into st raised to the power negative half. I have 2z s open bracket st then raised to the power negative half. So this is the partial derivative of w with respect to t. So thank you so much for being part of this class. I'm expecting you in our upcoming class. Bye.